Assalamualaikum. This is the part 3 of the metal forming process. Today we will discuss on the forging process. So as you can see from the videos, this is the mind map of metal forming. In metal forming process, today we will discuss only one process, which is the forging process. So in forging process, there are many different methods which we can apply. The first one is a open die and closed die, precision die, upset die, and also we will discuss the coining process. Forging process is a process which using the compressive force, which we apply through the various die and toolings. Usually the die is a two die, lower die and upper die. Forging process can be done in room temperature, which is we call it the cold work process, or elevated temperature, which we call it the hot working process. Usually the forged part had a good strength and toughness because the grain structure of the metal reduce and become smaller. And application of forged part suitable use for highly stressed and critical application. Okay. In the figure, this is the grain structure of the forged part, and the figure below show that the changes of the grain structure of metal before the forging process and after the forging process. So as we can see from the figure, the grain is become small and intact to each other. This is the comparison between the different process, the grain structure, the grain flow of the different process. The figure A show the grain flow of the metal casting. B is the grain flow of the machining process. And the C is a grain flow of the metal forming, which is the forging process. Okay, type of forging, as you can see before from the mind map. So we will discuss on open die, closed die, precision, upset, and coining. Okay, this figure show the open die forging. So there is two type of die, lower die and upper die, and between them we put a workpiece or metal or alloy, and then the die, either lower and upper die, move close to each other, and it will compress the workpiece behind in the middle, and the upper and lower die will not touch each other. This is the simple forging operation and very versatile, can apply for small and very large size of the part. Okay, this is the closed die. This is also the open die forging. So either we can use the open die to produce a circular part, rod, such as a rod. This is also one method of the open die. So it is very easy to identify open die. You can identify from the die, both die not touch or close to each other. Okay, this is the closed die forging. Okay, so we can see from the figure, the process occur in the closed die forging process. So we have the two type of die, upper die and also the lower die, and in between the die we place the blank or workpiece, metal workpiece, and then the upper die will move downward and compress the workpiece, the metal, and then the die, upper and lower die, will close to each other, will move and close to each other, very near, right? And in close die forging, we will get a flash. The product, when we open the die, we will get the product with the additional material at the side of the part. We call it the flash. The flash we can remove by using the machining. You can use a grinder to cut off the flash. In close die forging, flash is mandatory, required and mandatory. If you get the product without the flash, means that our product is not, maybe not feel in the metal may not feel in the cavity. So flash is required. So and then we can remove the flash using machining. Okay, and this is the standard terminology for the forging. I hope you can remember each the terminology of the part in the forging process. So this is the parting line. So separate between upper die and lower die, and then we have a gutter, the area for the flash, and then a corner, fillet, web, rib, and also we must have a draft. So draft, I think it's same with the metal casting. When we design the mold, remember we have to provide the draft, draft angle. Okay. In the close die forging, the process done in the several stages. So usually start with the fluring, and then edging, and then blocking, finishing, and trimming process. So means that we cannot simply apply the one die only to produce the part. So here they have a different die. So each edging have a different die, blocking have a different die, finishing have a different die. So means that the metal will be compressed using the different die and different stages. Okay, in the precision forging, so the name of the process will describe what happened in the during the process. Our product is very precise if you using this method. Also known as a flashless forging. So it is much better or improvement from the closed die forging, where using this precision die forging, we will eliminate the flash. So here we refer back flash. So using the closed die forging, we will get the flash, but in the precision, we will eliminate the flash. Once we eliminate the flash, we reduce the process, production process, and thus reduce the production time, and we can increase the productivity and also increase the profit. And precision forging is used to reduce the number of finishing process. So it's not required the remove the flash, because no more flash. And then typical products such as a gear, connecting rod, turbine, blade. Usually used to produce net shape product. Net shape product means the product is very close to the finished part. Okay, here show the precision of forging. So the raw material, the red one is raw material is a billet. We place between the upper die and lower die, and the compression, the upper die will move downward and will compress the material. So here we will eliminate the flash, and here also uh, precision forging. We place the raw material and then compress with the upper punch and lower punch. Okay. Okay, in precision forging, we require the precise control of blank volume and shape, and accurate positioning of blank in the die. So this is very important. And a special and complex die. So in precision forging, we must make sure the amount volume of blank or raw material must be properly calculated and placed at the right position in the between the die. Okay, this is the advantage of metal forging. So it's a versatile process. We can increase the productivity, especially when we apply the precision forging. We can save the money because we reduce the processing time, reduce the waste. We can get the near net shape and save material. We can get a stronger and tougher material. It's a simple process, and also we can reduce the number of process, and also we can reduce the scrap. Okay, thank you very much. We will continue for the next series of the lectures.